Yeah, so singletons. I mean, like I said in the beginning of the stream, like this is since the beginning of time. I made my first singletons in C++ back in 2008 maybe, and that was a completely different thing than singleton is in C sharp, generally speaking, at
Yeah,
least in mono behaviors. In C sharp managed land.
sure. Yeah.
Um, but so. So let's just quickly let's think about and before I show anything, let's think about what I mean with singleton. So a global place to have a specific set of data that you should only have one of them. It's not that like it only needs to be one. No, it needs to. It cannot be two. That's a bad idea, and then it's not a singleton, and it should be basically globally accessed. But the globally accessed part is a little bit irrelevant because data-oriented design, generally speaking, is like nobody cares about encapsulation as in object when as you do in object-oriented type of programming.
Right.
So in object in old school game object unity, you'll have like some class static accessors and tricks to be able to have like I can get this singleton wherever I am in the whole game, and it's not encapsulated into behind anything really. It's just like straight up, and you can just access it. That part of it just automatically by default, sort of in data oriented design, it should be just accessed globally, like everything else in data oriented design. But keeping it one globally and keeping it effective. That's the two things I was concerned about when I started thinking about this problem back in maybe 2019 or something. So the first thing, let's just take a look at one thing here. So I've just mocked up a few things here. So we have three different I component datas with some random uh, data inside. You can imagine this being some global constant data loaded in from somewhere, and then we have some game mode state which may change during the game or whatever. And normally you would do something like this, right? At least in Unity 1.0 and forward, you would use
Hmm.
this nice and dandy create singleton thing that comes with the entity manager in the source code of ECS.
Right.
And like I think this is a good thing, but I'm a little bit confused why they haven't like made it so you can target a single entity. Because what happens in the background here, if we go to it, is that this it creates an entity with the
Right.
specific archetype. So just an entity with just a single component on it. So if we were to run this, let's see if I can get everything up and running. We can just have it paused, and we take a look. We'll see here that this code generated these three. So it's nice that they have automatically put the name of the component of the singleton component. So
Yeah.
that
Yeah.
makes
Yeah.
it like easier from inspection in this
Hmm.
hierarchy type of thing. So if we look at this, we have the game mode state, we have the two big matrices, and we have our other things. So that's three different things. But uh, there's one chunk, or at least one chunk per archetype, and these are three different archetypes. And correct me if I'm wrong, but the chunk is 16 kilobyte, I think.
Correct. Yes.
So we have 3 times 16 kilobytes for these three things,
Yeah.
and this is not 16 kilobytes. That's way, way, way less.
No, I think that's
Uh,
like 128 bytes.
Something like that. Yeah, it's very, very a lot, very small. And maybe also this is developing, this API or this function didn't exist before 1.0, I don't think. So it might be, Unity are making my solution, which I'm about to show, us slightly obsolete soon. I don't know. This is the way I solved it. So instead of using that, I have this thing, singleton utilities, I call it. And this code is through the thing. Never mind. We can talk about that later.
Okay.
Um, uh, if we go here, we can take a look at what I've written. So I have a static class which is basically all extension methods on the entity manager.
Right.
So I just want to have access through the entity manager straight up. Even this one, which technically doesn't even use entity manager, I still just have it through the entity manager, so I have it all from the same one. In the setup here, if we ignore this, making sure we not already have a singleton setup, it just creates straight up an entity and it puts one single tag component onto it. And then I just use these guys, create or set and create or add. So what I do is that I have this static entity, which is one for the whole game, right? And when I go in here and I'm like, I want my specific singleton right now, I want to create this thing.
Yeah.
I send it we can look at this from the other side, actually, it's easier. So create or add or create or set. And this basically means that if it's already existing, it will overwrite it. That's why it says or. And add means that you don't have to set anything. And set means that I need to put in like an instance of the actual component to it.
Yeah.
Otherwise, it's just like default
The
data,
default, yeah.
000 or whatever. So when we go here, it just wrong button on my keyboard. Let's see. There we go. I'm getting used to the mic in front of me.
Oh yeah.
So create or add, this was the wrong. Yeah. So this one, since it's, add, it doesn't set anything. If we already have it, it doesn't even do anything. If we do using the create or set, then it's like, if we have it, we set it. If we don't have it, we add it with the data. So, basic stuff. And we always use this singleton entity thing. So that means, let's see here, if we go back with this code now instead, we compile with that. Just newly installed computer. I have auto refresh on. That's very, very strange to me. Let me actually take that. Where is it?
I don't
Assets,
remember.
pipeline? No,
yeah,
general.
It's one of those things. You set it up once and
auto
don't.
Maybe I shouldn't look here. Half of the verify. I don't actually remember where it is.
Yeah, I always have to look it up every time I have
to auto refresh. There we go. All right. Yeah.
There you
go. So now we have the other thing, the other code enabled. So now we don't have this nicely named, but that could probably be solved if one wanted to do that. We have this entity instead. And if we look at that, we have the default singleton tag, and then we have all of the three ones. So this means that all of these share the same 16 kilobyte chunk, which is,
Yeah, that's
16,
awesome.
Yeah.
That's a ton of data.
In the context of your CPU, let's do that. That was my new computer being very annoying and wanted to restart for
Swedish.
Update. In Swedish, I have to flush it and install English again. Anyway, so 16 kilobytes is not a big deal, but it's a big deal on the inner cache. That's where it's annoying to have 16 kilobytes unused, right? Because the other part of the chunk will be completely unused. And if you have, let's say, a modest 20 singleton component, that will quickly stack up to a lot of just empty. Damn it. Sorry about that. It wants me to activate. I haven't written in my key yet. A lot of 16 kilobyte chunks, basically empty, just stacking up. If you have 20, I think I have about 50 singleton components in mine. So I might be actually running out of the 16 kilobyte chunk space at one point. Who knows?
Yeah, it would be interesting to see. I would be curious about an in production
what size
singleton,
of it?
What size you're at and how much overhead you still have.
Yeah, and just side note, if I run into that, I have already thought about that issue, and there is some slight categorization I can view, categorization lens to view my singleton through, where I get two different categories of singletons, one with constant data and one with I have blob assets for most of my constant data, but some are not, and I can just put that constant data singletons on its own thing, and then have all the variable singletons on the other, on so I can split it into two
Hmm.
singletons.
That's a good idea. So then, like, especially because like looking into like data dependencies, if you're only reading from data on one entity, then there's going to be, it's not going to
Yeah,
have those, you know, flags and all that of,
exactly,
yeah,
exactly.
write
So
access and everything.
that but also uh, one could probably just Google this quickly if one wanted to, but maybe Unity already solved this if that would be an issue. I know it wasn't solved originally because Stanlock ran into this issue with super huge components, and which wouldn't fit into a single chunk. But maybe that's
Right.
solved, so this will just automatically just continue working if I break the 16 kilobyte barrier. Anyway, back to the examples here. So this looks much better, right? So so this means a few things, which is very nice. So we can take the first thing, which is kind of annoying, and then we take all the nice things. So one thing here, for some people who haven't worked a lot with dots, maybe this is very strange and you haven't seen this, but we have an API call which allows you to get the singleton and get the actual source data behind it.
Right.
So you can modify it. Otherwise, if you just get the singleton like this one, you will get a copy of this specific singleton component, and changing that won't change anything. It would just change this local copy of it. But this one, you can do read write value, and if you write like that, the actual source data will change. And but that's only through get singleton, this generated code. I have tried to
Right.
replicate it, but I haven't figured it out yet how to replicate this in my own with my own singleton. But that means that we're basically doing looking up through queries and everything, finding your exact singleton like old school the normal style, just to find one data component and having read write access to it. Uh, just for this RV version of it, you'll have to go back to normal system API calls. But if you are just reading constant data, you don't have to use this type. You can do like this: entity manager get singleton, have your own overloaded version, which just gets the data without doing a query to find which chunk you're at, because you already have as one global static entity, which
Oh, yeah, yeah. So you already know, basically.
I
Yeah.
already know. And I don't think queries are at all performance issues, but there is something going on behind a query, so
Yeah, yeah.
doing
Just
this
kind of
got to
remove
be
a couple
slightly
steps. Yeah.
faster. Yeah, and also this is not burstable. I think there's a way to do this burstable, but static variables like this are simply not burstable for race condition, basically parallel thread problem thing. That's not necessarily burst, but it's still like tied into the whole uh,
Okay. I
bundling up
see.
the code into a perfect, nice, neat package and executing it bursted. And static, there's something called shared static, which might be possible to use that. I've experimented, but I have zero performance issues with this, and I have very few cases where I would need to, where I want care about this problem. But if you're not bursted, you can use get single. You can just use it like this, and you will get probably the result slightly faster. So that's one nice thing. The other
Nice.
very yeah. Do you have any?
No, no, this is awesome.
Yeah. The other very, very nice thing, which is way, way more like just convenience thing than anything, is so if we go back to this thing, um and I have a little bit of a print statement somewhere. compiling. Why is it compiling now? I thought and we take, oh, I did something. What did I do? Let me just go back all the way so it doesn't. Oh, probably that. There we go. Live coding. It's always gonna
Fun times.
be weird. So I have a print. We can ignore those, and I have another print. I thought, oh right, I'm using your disable auto create thing. So now we're gonna get a print. Yeah, this one. Global game mode state, global data, and global data 2 is not on the same entity. So if we go where this is coming from, it's coming from a burst system. This one. So imagine you're having game mode code, which obviously you execute like globally for all players or whatever, if this is a multiplayer game, or for all enemies or something. But it's just one single, it's a singleton logic, sort of. Then imagine all of these three being on separate entities. Then you will need to, do the query for the game mode state, which you might want to change. And then inside of here, you can pick out the two singletons. But you still need to pick out these two data manually, right? And we can ignore that one. That's just for my logging to be more clean. So you can see, like, yeah, you can't do a single clean for each loop on a single chunk to be able to access all of the data you need. You need to, like, oh, this singleton over here in that chunk and that over there, and you need to gather it up, and then you can run your singleton logic for your game mode or whatever here. But if you actually go back to this solution where you put everything on the same one, maybe you already see where I'm heading with this. And let's see if I can reload it. That should be it. Game mode state, global data, and global data 2 is on the same entity. And we can look, we looked at this before, straight up same entity, which means that the code can look like this instead. So you just query for everything you need, which in a game mode type of logic is often just singletons. Maybe it's like a list of all the positions of the enemies or something, or something like that. But it's generally speaking like a singular orchestrating code that just does a bunch of things with all sorts of items and
Right. So
things
instead
around the
of
map.
having to look for all the different singleton entities, you're just going to that one single singleton, and
Yeah,
then
which has
just getting all the
all
data
of
off
them.
that.
Yeah.
Yeah,
So,
yeah.
so this is all my game mode code in just read instruction comes through a single update loop like this, where it just runs once with all the singletons nicely packed into a single chunk and nicely updated.
Nice.
So this is actually, I think that's the most underrated. That's the most useful part about shoving this together. It's not performance. It's just convenience. It just looks much cleaner to do it that way, and you will have write access to all of these. If you do the write, whatever it's called,
Ref RW.
right, yeah. But or if you do it through other type of iteration methods, like the jobs or the old school entities for each, all of these, you can just have straight up an update which takes care of the whole thing, and it's all nicely packed in memory. So yeah, those are the nice things about how it turns out to have this single entity singleton. Let's look at a few other examples of things that is like not necessarily different, but to think about. Let's see here. What do I have changed here? There we go. So reading from so this is general. This works mostly the same in if you have the single entity singleton, or if you have the other one where it scatters them around. But I just wanted to show some examples of how it looks to read from this singleton. So imagine we're going through transforms. Maybe this is the player loop. We're doing something somewhere. Um, Normally, you just read the values. You have to pull it out in a local variable like that, and then you can read it straight into run, and that doesn't change anything either way you use it. um, and with this type of a read, you can do it super parallelized, doesn't matter. So, and here we have the same thing, schedule parallel. All of this will just be totally fine, right? So, and this is just mock-up logic. There doesn't do anything. It's just like some if statement to have something. Then we have this thing also. So if you have the singleton again, and again, this is more generalized thoughts around singleton. If you have this read-write version of it, imagine you're writing something. Oh, the last time a player was killed or something. It's a global variable that you need to look through all the players to find out and then shove it back. If you have it in a run, then you can use this read-write version of it. You see, we get the read-write value, and because it's a run single-threaded on the main thread, we can write directly to this one without any problems. And that didn't exist when I started, the read-write version. So make sure if you're using singletons, and a lot of game mode code, if not all, should be main thread run, maybe schedule, but probably run, because it will probably not be heavy stuff going on there. So it can just make sure it's bursted, and then you can have this thing. And this is for every player maybe, or something like that. So it's not necessarily the single logic executing for the game mode. It may be logic executing for all enemies, or for all object, or for all players, but you can still have read and write access to a singleton inside of it and make your code cleaner.
Yeah. No, that's great, because if you didn't have that, then you would have to do a get singleton, modify the data, and then do a set singleton.
Yeah.
Which I think is something that I've definitely done in some of my recent tutorials. I'm thinking of if I did that in the netcode for entities one or not. I know that I for sure didn't use the get singleton RW, but I don't remember if I'm doing any singleton actually setting in there.
These kind of API upgrades are very nice and very annoying at the same time, because you I have 500 times I do this in the old
right.
code, and it's just in my body to think about not swapping all of them out for the right proper one.
God, so spend a weekend changing all my get singletons over to
I already spend so much time on exactly that type of issue, because I can't stand my own code when it's doing something very unnecessary. So one day my game should come out also. So that's a balance you have to make.
Right.
V-Rising was launched on version 0.17 for that reason. They're like, nah, screw it.
A heavily modified 0.17.
Oh, yeah, heavily modified. Yeah, that's for sure. Then, so let's take a look at the weird edge case here, just because of this singleton paradigm situation.
Cool, yeah.
So if we uncomment this, so this is actually a callback to my quick tip for 2 weeks ago, where I pointed out a problem with structural changes and having to pull out another copy, or another the dynamic buffer once again to make sure. And you can go back to that to see how I solved that. But this is a slightly different situation, which doesn't have a neat solution really. So here, I pull this out. I do some stuff with it, who knows what, and then I do something which is explicitly a structural change. So this just means that if I have the component, I remove it, and if I don't have it, I add it again. So it just flips just to make sure something technically structural changed have happened here. And then we use the same global data RV that we picked out here. We try to use the same to use that one to try to push in some new value. And if I run this, let's hope, yeah, ignore these ones and just focus on this. Attempted to access this global data, which has been invalidated by a structural change. So that means that this thing made this singleton reference, if you want to call it, invalid. And there's a ways to work around this. There's several ways, but the easiest way I've noticed is just pull it out again. Don't muck
Interesting.
about. Just like, yeah, it's probably the same, probably not a very nice cache hit at the same memory location, but just do what the memory safety wants you to do and just pull it out again. All right, it's fair. um, other ways to solve this would be to, have a copy, not the reference to it, and then write to it through a component lookup thing. But like, this is almost simpler. It's just a little bit annoying to have to write the same
Yeah, it
line,
probably
another one.
resets the safety checks or something.
Yeah,
And
yeah, yeah. And I think also there's like 99.999% chance this has not changed through that thing. But oh well, it can actually swap chunk, so you move it literally to another part of memory, and that might actually make this reference completely
invalidate it.
actually invalid. So you
Okay.
know what? Forget about the last thing. I actually think that this might actually screw it up. Anyway, that's it for that one. I have one more thing to show you, to show that's probably relevant for most people who just haven't used singletons as much. So first of all, we can, if we uncomment this, we see what's going on. So here we have basically the same code as before. We just write some random stuff into singleton. Either of this, I don't know, maybe they compile. Actually, that could be the case, that they are compiling. I don't remember. But I think they both get the same. Yeah. Schedule this job uses unsafe pointer, which is not allowed. So behind the scenes in the singleton reference, you have a unsafe pointer to the actual place where the data is. And they're like, if you're gonna schedule something, it can't be pointing out away from the job, and you need to have a contained local copies of everything. So if you have a
Mm,
pointer which points out of the where
right, because
some
multiple locations could be
you know
modifying that data basically.
this everything you put into this lambda expression here, or any type of job like that in the job system, it sort of captures it and with local copies. And if you have a way out through a memory address, then you can get out of your little safe box. And that's basically what Unity job system prevents you, and makes very nice and tidy for you. So you're in this job box, and everything is just, unless it's native arrays, native collections, you can't get out of it. But with native collections, then they have all this dependency tracking built into it, so they are able to communicate in and out, right? Otherwise, but this global singleton reference points out, and the safety system just, no, you can't have a way out of the little safe box. So you get this unsafe pointer are not allowed. Maybe there's a way around this in schedule, because technically schedule, is one thread. So maybe
Right.
that one thread could have access to this singleton thing. But I don't think so. I have not found it, but I'm unsure. In schedule parallel, it definitely, this is like the clearest race condition you can imagine. It's like just 50,000 threads shoving their own values randomly into the same thing, and they will just, no, this will
Yeah.
instantly give you race conditions all over the place. So yeah, that's how you cannot write to this one in parallel in any way. That's what the safety system is for. But remember, you can write to it You can read from it very easily. Schedule parallel reading from it, because this is a copy and does not have a pointer out to the actual value. It's just a copy. And
Nice.
then, yeah, questions, or is it clear?
No, no, I think I'm set for now. Yeah,
Yeah.
that's good.
So yeah, I have one more last thing, because like if you never worked in parallel situations before, dot sort of gives you a nice way of getting onto it, and you can try to just parallelize a bunch of entities, and it just works, sort of, right? But it works working on the actual entity that you're going through, right? So communicating out of a parallelized job, which you do a lot of with singletons. You need to like communicate out something, a singular point, like, oh, some enemy went and did this, and you need to have global knowledge about that one entity went over the edge, or whatever, one enemy um, went over the edge, and you need to know that. So how would you do that? So here we have a write job, and it's named correct because it's actually works, and it's a good way of doing it. So imagine here you're going through all local transforms, and you shove something in, some data. This is again the copy, a singleton data, and you have like, oh, if he's too high up, then we need to know about it, right? The only really way to do this serialized, parallelized, is to have a parallel writer. So I think native queue is the best one, and this is, a huge subject to talk about the different types of how different collection works. But this is
Sure.
just an
Yeah.
example how it could work. So native queue by default is not thread safe, but you have this sub structure, parallel writer, which only lets you write to it, uh, and then you can just, oh, somebody went out. It doesn't really matter, but by just the fact that we're putting something into this native queue, uh, we the next frame later then. So let me just point out how this goes. So when I set up the right job here with my data, which is my native queue, um, this is the one I'm writing to, and then, so this is the same, right? And then in the beginning of the next frame, then I can just check like, is the count of data not zero? Then something happened inside of that job. So that's like the main way you can communicate a single global event through parallelized code. You need to let all the different threads, or different cores or whatever, have a way to like thread safely just put their result into a queue that handles all of them shoving at the same time, which this parallel writer does. So that's a very very straightforward way of communicating out. You will have, a full buffer of stuff coming out from all of the different parallel threads doing their thing, but that's the thing that you then sort through in single thread mode afterwards. But hopefully all of the different threads have, did as much processing as they can, and then hand this off to the singleton type of code that's gonna zip through it and make sure that, oh right, there's some enemy just went outside of the map in the y direction, let's handle that. But that's, so yeah, and that's once again like singleton type of managing data,
Right. Yeah.
and how
That
that works with parallelized. Yeah.
that kind of is similar to a little bit about what we were talking about last week with the damage system, about how you can kind of like, queue things up from parallel threads, or, different jobs and everything like that. And then at one point in the frame, you kind of, go through all that data and then actually apply it where you need it.
Yeah, yeah. And I have one example, one last example here of a problematic, and it's not, this compiles and runs just fine, but it's to point out how you can be tricked by this, especially with some built-in nice things from Unity that doesn't really work as you want them to sometime. So here we have basically the same situation here, but instead of communicating out through a native queue and just like having like, is there anything in the native queue, and have that as the signal. We are trying to update the global singleton data, and say like, oh, we enemy went out, and we need to detect that in the singleton data, or singleton
Right.
state, or whatever you want to
Right.
call it. So we have this if statement here, and then somebody went over and we set this value, and then we use this parallelized command buffer, which delayed writes directly to the singleton data. So I
Mm-hmm.
have this, I set up, so I have the entity that actually holds the singleton data. I have that here, and then I have the command buffer, and I set this new set data onto that command buffer, and then later in the frame, when we're not parallelized anymore, the Unity will the ECS code will execute this command buffer, and it will set this global data onto the actual singleton that we have in our data set. Which, nice, we detected. Value 2 is 4. We know that enemy is above the value or whatever. However, in this case, this sort of becomes a little bit weird, because you can have 10 different enemies doing this,
Right. I was gonna say, yeah.
and you don't know how many, and they're all gonna run in different. You still sort on this entity indexing queries. You still have a sorting thing, which makes this command buffer apply the changes in a predictable manner, but it's just predictable. It's not determined in a way that you might expect. So this is just bad habit. It will work. It will probably do what you expect it to most of the time, but it will have like a hidden race condition. So because you can have 10 changes to this singleton data that's just execute, and all of them will just overwrite the other one just in a long
Right.
line.
Right.
Yeah.
Yeah. It's just like whichever one was the last one is the one that basically gets applied.
Yeah, with this one, you still keep like separate elements in a queue for every time this thing happens. You can count them up afterwards. In this case, you can't count anything up afterwards, and like that's just because that's how command buffers works. They are not. They're not very good to communicate out singleton types of data out of a parallelized job.
Right.
Maybe very esoteric specific situation, but I've dealt with this problem a few times, and so I wanted to show off how I solved it.
Yeah. No, no, that's great that you mentioned that. And by the way, I'm sure Danny is probably shouting at his screen right now for you using entity index and query. The one that you should be using, I believe, is chunk index in query.
Oh, yeah, maybe actually for the sort key in yeah, that's
Yeah,
probably
the
right.
reason being is because if you calculate, because like the entity index, no, not even entity index in chunk, it's chunk index in query. So each
Ah,
chunk basically gets a unique index, because all you need is a unique index so it knows kind of the general order to play them back in.
yeah,
So if you do entity index in query, it actually has to calculate the entity index for every entity, which has a little bit of overhead with it.
yeah,
And so if you
yeah, yeah,
just
yeah.
use chunk index in query, then you know whatever chunk that you're in, it just already has that chunk index.
That makes sense. That makes sense, because like this index here, it just doesn't really matter what it is. It's just
Right.
supposed to be
Yeah.
predictable,
Exactly.
and so you don't really need to care exactly what it is. And this is much faster to calculate than the other one. I've actually used the wrong one in a different situation. Had super a huge amount of issues with this index, because there's three of them to choose, and I chose the wrong one, and all of them are like the exact same length,
Yeah.
and
Yeah. Yeah.
contains
Yeah.
like
Yeah.
80% the same words. So
Exactly. So if you're just at a quick glance, it's just like, oh, that looks fine.
yeah,
Yeah.
yeah, but yeah, good catch, good catch. And lastly, there's two slight pitfalls. There aren't really pitfalls, they're just something to be aware of. First of all, remember, this is a specific, if I set this up the very first entity in the world, so I know that it's like entity 0 or whatever, um 01 I think it's called. So that means that when I have a situation where I can debug my client server communication with multiple worlds in the same editor, and it all works because it's just the same entity index on both worlds, but it's technically two different worlds using the same singleton entity. So be aware of that. If you have multiple worlds, this will not work unless you're very, very sure that they end up having the same index in both of the worlds. Uh,
Interesting.
yeah, I think there's a way to do this pretty cleverly and make it like have a list of like, oh, for this world, this is the singleton entity, and for this world, this is the. But that would
Kind
probably
of like how you
mean,
can assign like the default game object injection world,
yeah, yeah,
like a
something like
specific
that.
world. Yeah.
But I think any solution to that multiple worlds problem will probably take away a little bit from the performance gains of it, because then instead of doing query stuff, you do some sort of lookup in a table
Mm,
to find whatever world you're in and where what. Yeah, so for me, it's just easier to create this singleton entity the first thing you do in the world and make sure that's the same, and then just don't care which world you are on.
all right. Hey, if
Yeah.
it works, it works.
Yeah. Use you with on your own with caution.
Yeah. Yeah. Yeah.
Yeah.
Yeah.
And then the last one, remove singleton component if exists. This isn't really like a problem or anything. It's just that um, this is remember to remove the component, not delete the entity. I made that problem a few times where I was like, "Oh, this it
Where's
has
all my
then,"
data
and
go?
yeah. And also like this is generally just a nice extension method to have, where you can just remove stuff if it exists and don't do anything if it doesn't exist, and have like a slightly silent failure. It's not a failure, a silent like skip. I don't think, maybe there's something in the newer versions of ECS that does this,
Yeah,
but for
I don't
me,
think you need to have the has component check.
I had a lot of issue. I have a lot of like warnings and stuff going all over the place when I
Yeah, yeah. But I mean, you have it in place, so it's like no
yeah.
need to. If it ain't broke, don't fix it.
Yeah, and also you can do the same with singleton buffers. Exactly the same solution, and try all of these things that you normally would do with the singleton in the normal system API. Most of them can be replicated easily with this singleton entity thing. So just go ham with that and try to find something that fits easily in your type of coding. Yeah, and just for fun, this was my attempt earlier today to replicate the RV thing. Um, this is what Singleton RV looks like behind, with a bunch of safety added that I've removed. But it appears that this one is internal, so I would need to modify that and make it public. And this index in archetype, it's more or less impossible to get unless you're using a query, which this
Hmm.
one is supposed to avoid. So I don't really know how, if I could make the singleton RV work, but you can just go into the code, find the thing that you want to sort of have but slightly different way, and just copy it in and try to make it work. The source code is just straight up there. Yeah,
Sweet.
that was it. I think that's how I manage singleton in my game.
Awesome.
I
Yeah,
have a
that
hundred
is a
thousand 100,000 lines of code in my game, and everything is based on every singleton decision. The code is based on this pattern. So I
that's
guess
awesome.
that works.
Yeah, this is an excellent solution. I really like you have the good memory savings, and I think you're taking into account a lot of the job dependencies and everything. And yeah, this is something that I would certainly like to use in some of my own projects because yeah, I mean it totally makes sense. Just store that stuff all within the same chunk. There's no reason to break it up and just have all that empty chunk data.
There is one annoying thing with this. When you select the singleton in a mid-game situation in my game, and you want to see all the inspector view of it, uh, it lags. It takes like two
Takes a
three
while to
seconds
load.
for it to load in all of the different things. I don't know, it lags certainly more than a normal entity because
You
it
have to
just
load in
have
like a
all
couple
the different
kilobytes of
stuff.
data.
Yeah, but it should not, it should be only be one chunk. So I think the inspector thing is doing a lot of fancy trickery around to make
All
some
the
UI thing.
property drawers and everything.
Yeah, I don't
Yeah,
think
yeah,
it's
yeah.
actually the data. I think it's more
Yeah, yeah,
about the
yeah.
debug
That makes
systems
sense.
around it that really doesn't like my gigantic entity.
Cool. Well, that sounds great to me. Thank you very much for sharing.